take a human skull, you can basically, that line divides what's called the viscerocranium or the splanchnolocranium or the facial cranium, and that's the face. And behind it is the neurocranium, sometimes called the chondrocranium, because the ones above the line are membranous bones. The big flat bones, the parietals, the frontals, part of the occipital, part of the temporal are membranous bones. So they don't form the same way. So how do we get these things to grow? Well, this is a fetus, 12-week-old fetus, and the bone is stains in red, and the cartilage stains in blue. So you can see already you're getting this, these things are starting to form. And if you look at that little mandible, there's a strip in there called Meckel's cartilage. You got to remember this. This is the big one. And Meckel's cartilage, I'm going to tell you right now, comes from, anyone know which pharyngeal arch? One, right. Comes from one. But here's the question. Does the mandible form from Meckel's cartilage? No, it does not. What happens is it ossifies around Meckel's cartilage and then it resorbs. But there will be a question in your life about Meckel's cartilage, and does the mandible, is it directly formed from Meckel's cartilage? And no, it does not. And Reichert's cartilage is the same way.
Can you point where that is? I
Yeah.
didn't catch where that is.
Oh, I guess I can use this, huh?
Yeah.
Cool. This thing. That little bar, it's right there.
And then that, would you say it dissolves or?
And what it does, it forms a basis for cartilage to form around it, and then that cartilage then calcifies, and then the original Meckel's cartilage then dissolves. It resorbs into the body. The point being, it does not directly form the mandible. And that's just the facial skeleton. Differences there. You all know those guys. This is another way to separate it. All of these things are membranous bones. The occipital is partly membranous. Down here in the basal part of the occipital, it's not. And you have that basal occipital synchondrosis, which is important for aging. Doesn't fuse until about 12 or 14. All of this stuff is facial skeleton, obviously. These are the bones in the facial skeleton. You know all these guys. I hope. Now, here's a mandible. This is what it looks like at birth. It's not very well formed. Of course, there are no teeth. This is an adult mandible. So how do we get from that to this? Well, I can't help myself. I have to do this. This is branchiostoma. Did any of you learn about this in embryology or biology as undergrads? God, you're so lucky. This is a little worm that lives in the sea in Asia. The point is, it's a notochord. It doesn't have teeth, but it's got little tentacles here. It buries itself in the mud. It filter feeds by pulling in water, and it washes out through the pharyngeal slits. It has a head end and a tail end, which is a good thing, as we talked about. It also has a notochord, and above the notochord is a hollow nerve cord, which is, say, the spinal cord. So the notochord in humans, which is what do we have left of the notochord, you know? It's the disc between your the intervertebral disc between your vertebrae. That's the notochord. What's what we have left of the notochord? Actually, it's the nucleus pulposus of the disc. And we have our spinal cord, our nerves, running above the notochord. That's an interesting thing, because for years anatomists had a terrible time trying to explain how a lot of invertebrates have flipped that. They don't have it like that. They have their spinal cord underneath the notochord, or what would be the notochord. And then as tetrapods, we flipped it. Well, it seems like a very difficult thing to do. It turns out it's one gene, so it's not a hard thing to do. all I care about this little guy are the slits here, the pharyngeal slits, what we would call gills. And all tetrapods, what phylum, if we look at the zoological nomenclature where you start kingdom, phylum, class, order, family, genus, species, what kingdom are we? Are humans? No, we're animals. What phylum? We're chordates. And chordates all have a notochord, they all have a spinal cord, they all have segmented muscles, and they all have gill slits embryologically. Very, very conservative. So where do the first jaws come from? Well, they come from the bones and the muscles that used to work the gills. And then they turn into jaws, and then we've developed teeth that come right off of the armor, the scales, and the jaws, but the important thing here, the jaws and the muscles. And remember, when a muscle moves, when it migrates, because evolution wants it to do something else, it almost always drags its nerve with it. So that's the way you can start to tease out what muscles do and where they come from. We've already talked about this. This is a primitive mammal, more like a reptile almost. And what is listed here as a dentary is what you would call a mandible. The squamosal is the occipital bone. But importantly, the TMJ is made up of a quadrate and an articulate, these little tiny bones that form up what we would call a TMJ. And they have that because they only use a temporalis, and the temporalis creates enormous force on the glenoid. So when we developed the master, we removed that, and that meant we could steal that quadrate and the articular, those two little bones, and we stuck them in our ears. And we turned them into the malleus and the incus. And that's why we hear well. Look at the size of the cochlea. We couldn't fit it in the petrous portion of the temporalis anymore, and we actually had to coil it because it got so long. Not so in these little guys. We also invented an eardrum. They don't have an eardrum. But importantly, we took the incus and the malleus, and remember, we took the same innervation. What innervates those guys? Which pharyngeal arch? First. Same thing that does master and temporalis. Remember, those are jaw muscles. We took these that used to be a jaw joint and stuck them in our inner ear, but we took the innervation with us. Now this is important because if you get somebody that comes in and has obviously a first